Today, we're going to learn about the UV editor. First, create a cube. Assign a Lambert shader, and connect the 2D texture. Checker to the color attribute. Press 6 on the keyboard to display textures, and you'll see the checker pattern applied. Now open UV editor from the modeling menu. UV is a coordinate system used to unfold a 3D model onto a 2D plane so textures can be applied. Just like unfolding a cardboard box into a flat sheet, UVs flatten a 3D model into 2D so images can be mapped onto it. This time, let's dock the window on the right. When you drag the window near the border, a blue highlight will appear. Drop it there to dock the window. You can also use the panel menu. But manually docking the window like this is very common. Use whichever layout feels most comfortable. In the UV editor, the horizontal axis is U, and the vertical axis is V, similar to X and Y coordinates. The UV space is divided into tiles such as 0, 1, 1, 2, and so on. The first tile where the checker texture appears is U1 V1. The tile next to it is U2 V1. We'll cover this tile system in more detail later when we learn about tiling and UDIM. First, let's take a quick look at the icons at the top. The second icon displays each UV shell in a different color, making them easier to distinguish. The fourth icon displays borders around UV edges, making the boundaries easier to see. This icon shows or hides the UV grid. This icon turns the texture display on or off. This icon displays the U1 V1 tile and the checker pattern, allowing you to check whether the UVs are unfolded correctly. The last icon darkens the texture, making the UVs easier to see. Now, let's take a look at the cube's UVs. Move your cursor over the UVs and right-click to access the UV shell selection mode. You can think of a shell as a single connected piece. Since the UV layout is currently connected, it is selected as a single shell. Now switch to UV mode. You can now select individual UV points. Although it is a single vertex on the 3D model, it can be split into multiple UVs when the model is unfolded. As a result, one vertex may correspond to multiple UV points, each of which can be selected and edited independently. When you move the UVs, the sampled area of the texture changes as well, causing the texture to appear distorted. In other words, UVs are coordinates that determine which part of a texture is applied to the model. Now, let's make a simple change to the model. I've extruded the cube to change its shape. As you add new faces or modify the model, the existing UVs become distorted. Now let's fix the distorted UVs. Select the object and apply UV, Automatic. You can also find this option inside the UV editor. Automatic mapping projects the model from 6 different directions to generate UVs automatically. In the UV editor, you'll notice that the single shell has been split into multiple pieces. Each shell can be moved or scaled independently. When you scale up a shell, it occupies more UV space, making the texture pattern appear larger. For simple projects that don't use UDIMs, it's best to keep all UVs inside the U1 V1 tile. Select one shell and move the others out of the way for now. We'll work while viewing both the perspective view and the UV editor. When you select a UV edge, the connected matching edge is selected as well. Open the Cut and Sew section in the UV toolkit, and you'll find Sew and Stitch Together. Both of these tools are used to stitch UV edges together. Sew stitches the UVs together without moving them. Stitch Together moves the UVs while preserving their shape before stitching them together. This time, I'll use Stitch Together to connect them all. Be careful not to stitch the outer border edges together, or the texture may become distorted. Now the UV shell has become a single connected piece again. Next, Select a UV edge again and let's look at the cut tool. Using cut separates the shell again. The cut tool lets you slice UV edges manually, just like using a knife. You can also select faces and use Create UV Shell to separate them into a new shell instantly. To join them back together, simply use Sew. The Sew tool lets you stitch UV edges together by brushing over them. Similar to how the cut tool works. You can adjust the brush size by pressing B on the keyboard. Press Q to exit the tool. After editing, the UVs may become distorted. When that happens, use the Unfold section below. Select the UV shell and click Unfold. This automatically unfolds the UVs to match the shape of the model. You can then click Straighten UVs to make the UV layout cleaner and straighter. Cut, Sew, and Unfold are the 3 core tools you'll use most often when working with UVs. However, there is one important thing to keep in mind. If your model contains n-gons, overlapping faces, or unwelded vertices, Unfold may not work correctly. Now, let's take a look at UVs on different types of models. We'll use the apple model we created in the previous lesson. Since we've been modeling, the UVs haven't been properly unfolded yet. Everyone has their own workflow for creating UVs. Personally, after finishing the modeling, I first combine the UVs into a single shell. The easiest way to do this is by using planar mapping. Planar mapping projects the UVs from a single direction. It's commonly used for flat surfaces or when projecting from one side. This time, I'll project it from the Z-axis. As you can see, the UVs have been combined into a single shell based on the front shape of the apple. Now, let's apply the checker texture we created earlier. First, select the edge loop around the stem and cut it. Then select one vertical edge and cut that as well. Next, select the entire shell and click Unfold. If you see any stretched areas, add more cuts and unfold the UVs again. Repeat this process until you get a clean UV layout. Finally, you may notice that different UV shells don't always have the same scale. For example, one shell may be much larger than another, even though they belong to the same object. In that case, select the reference shell and click Get under Texel Density. Then select the other shells and click Set to match their Texel Density. That covers the basics of working with UVs. In the next lesson, we'll create UVs for a variety of different models. Thank you for watching. If you found this helpful, please subscribe and hit the bell for more Maya tutorials. Thanks.